Hi, everyone, and welcome to the EBO webinar podcast series. My name is Aaron Smith, and I'm joined as always by Nancy Bakeman. We're going to give a couple minutes to allow our audience to come in. So give us just about a minute and we'll get started then.
There we go. Okay, guys.
All right.
Oh, God.
We
Aaron,
did
Aaron, you're messing with an old man.
it.
And I got some good things to tell you.
You do. I know. We're very excited. Well, now that we've got our esteemed guest and great friend of Eva, Jay, successfully on the webinar, we've hardly ever failed yet, have we, Nancy? I just want to welcome everyone. We've got a great panel today. Incredible interest in heat pump water heaters across North America. I just put one in my house. I'm testing it out too, but I don't think we could have a better group to get a chance to hear from. So please put your questions in the Q&A section at the bottom of the screen, and I'll present those to our panelists as we go. But I want to turn it over to my longtime friend, Larry Acker. Larry is going to give an introduction of our guests today. Larry.
Hey, thanks, Aaron, Nancy, and Aaron, and Jay, and Marcus. It's always good to hear you. I want to, first of all, since I'm on the panel, I'll do a quick introduction of myself. I'm Larry Acker, and I'm the CTO of ACT Demand Control Systems. We've actually been working developing products for almost over 40 years, but in 1992, we invented the on-demand control, electronic control systems for managing hot water distribution systems for both residential and commercial. The first person on the panel tonight is going to be Jay Epstein. And Jay Epstein is the chairman of Healthy Communities and has spent the last 45 years building homes that are energy efficient with enhanced indoor air quality. He's built the villas at Rocket Landing, Virginia, first solar community of 45 single homes in Richmond, Virginia. Jay has won numerous awards in 2016, 17, 18, 19, 20, and 21. And in 22, he got the Department of Energy Housing Innovation Award. Jay's current community is the first zero energy home community in Virginia, located in Williamsburg, Virginia. His next community is going to be a first off-grid community of zero energy ready homes with solar involvement. The panel following him, the next panelist, will be Dr. Marcus Langer, who is a water physicist. He's a CEO and co-founder of Clean Blue. He's got 35 years of experience in water, wastewater treatment systems. His experience is worldwide known. He's got a PhD in high energy physics, Master of Science in Laser Technology, electrical engineering degree, and he's on several committees, including ISO, ASME, NSF, IATMO, as well as others. He's an expert on water reuse and treatment systems. He's developed state-of-the-art systems for water reuse that we'll be getting into at a later time. And he has been and now working with the major electric utility studying heat pump water heaters in the field of actual field operations. So these are two great guys to work with. And with that, I want to turn it over to Jay. Jay, you want to start with your program?
I'm going to go see if we can share now. Give me a second here.
Looks great, Jay.
Okay, great. Well, as Larry says, I'm Jay Epstein. I'm chairman of Healthy Communities. I'm a zero energy home builder. And I've been doing this since 2015. It is the pathway to decarbonization, and it was the framework of the IRA bill that was passed, in my opinion, in November. It involved reducing that carbon footprint. And how does that heat pump hot water heater work within that throne, as I would say, the beginning, as we look at our components that we add together to get to a zero energy ready home and to reduce that carbon footprint. A typical home has about 20,000 pounds of carbon that's released at the operational phase. That's when the homeowner moves in. Zero energy ready home reduces it down to a little bit greater than half, about 10,000. And as you add solar to that, it reduces it down to 1/5. So that's the pathway that I've taken, and is the other zero energy ready home builders have. And you'll see that now being incorporated in the new Energy Star and other building codes moving forward. So this slide is all about when I started, was 2016 with the DOE Innovation Award. And that's the first heat pump hot water heater that I put in that lower picture. And then my explanation on the right. But it reduces water heating costs up to 73% and provides a payback for 2 to 3 years. And the annual energy cost is $113, giving you an estimated $306 or more in annual savings. So you can see now how this component is working within the full building system. And that full building system, and we go back to that pathway to decarbonization and the bill, the IRA bill, 5 of the components that are looking at for grants or tax credits are the heat pump hot water heater. It is the induction cooktop, programmable Wi-Fi thermostat, multi-stage compressor, all electric home, and if you want a fireplace, an electric fireplace. So you can see this component is a part of our future. And then how does it work? I'm going to basically be really simple with this, but I wanted to show you the different types, of the integrated heat pump water heater and then the split system. And Marcus will get into that a little bit further. And what is a heat pump water heater? And I'm going to keep it pretty much to the builders. It's a compressor sitting on top of a hot water heater. And there's a backup element in it to make sure that you have choices when you cannot receive all the heat that you need from the air around the heat pump during different times of the year. And this one is, it's interesting because that's my cat. That's my freezer that we're looking at. And I never realized it till I started putting this together is, what's my cat always at the refrigerator? Thinking, well, maybe he wants food. He's actually trying to stay warm because my wife has the house so cold all the time. So that made me think, so what are the options available for your heat pump water heater? We know that it has a lot of conditions. It's not the simplicity of the build, but it's about how you can incorporate it within your building system. So we know that freezer or refrigerator has warm, moist air coming out as a byproduct of the refrigeration. Can we capture it? Definitely, we can capture it with a return vent that we could use with the that can be duct to the heat pump hot water heater and to the intake side. And then as you start getting involved with this, you're going, well, we build with conditioned crawls. We also build with conditioned attics. So that's a perfect spot to exhaust the air that can be ducted to this area. So it's easier to find a spot within the house itself to operate. There are consequences because, oh my gosh, this next one, duct your heat pump hot water heater, and it has its own rules. There's maximum lengths. There are elbows, consequences of using elbows, turns 90 degrees, and the accessories, how to tie it in to the heat pump hot water heater. Well, we can't expect the plumber to do this. So now we're going back to our mechanical that installs our ductwork. So it can be complicated, but it's just a challenge that we have to overcome. Another challenge is locating the heat pump water heater. This is a Shenandoah model that we built a rancher, and this is our laundry room in the red circle. Well, we're trying to get area that we can basically put this heat pump hot water heater, that it can not be duct, but draw the air within the house itself. So this was a simple redraw. If you look to the top right, to get the extra cubic square feet that we need, here is a doorway that we just moved over here and picked up 90 cubic feet. Down below, we went into this closet, this long closet, and we gathered an area, brought it back 3.5 feet, still have a 4 foot, almost 5 foot closet. And that allowed more square footage into the laundry room and a place for the hot water heater. So now we've picked up, and gained to 801 cubic square feet of area, which makes it work. And that's just an example. So if you're building something new, take the time and locate your heat pump hot water heater, or find a simple way to duct it in and out. In our area, and I call this the simplicity of the design, I'm in zone 4. So all my heat pump hot water heaters are located in the garage. And it just works, and the exhaust air is is helping to dehumidify the garage. The same thing with the exhaust air in that dehumidification, it can be used in the conditioned crawl or in a conditioned attic. But it doesn't affect the air within the house. The other piece of the puzzle is who to call. Now, when we talk about the components of the hot water heater, and I went through it very quickly, you've got that compressor and you've got that heating element. And if you have an issue, who do we call? Well, during the time period that I've been building, and you'll see during my recommendations, some of the issues that we had, but the manufacturers are coming to the issue and solving it simply: a 10-year warranty. Basically, if it breaks, they'll replace it. And soon others will follow in this component. Now we look at instant savings. From the marketing side of your homes, we look at 2 components in a home that have instant savings. One is your solar on the rooftop, because that's $1 back as soon as it's installed. The other is on-demand recirculating pump with the heat pump water heater. You'll see instant savings on those 2 components. And those are the only 2 components in this building system that you see that instant savings. A reduction of your utility bill immediately. When lessons learned on demand recirculating pump and the heat pump water heater, we had issues at the beginning because we would get air in the line. How did we make this work? So we ended up we removed the drain from the bottom of the heater to allow for a T back for the recirculating pump. Then we have a cutoff valve here. The handle is just moved to the back, so we don't want people playing with it. But it shuts down for bleeding the supply side to the return side, and the replacement of the circulating pump if needed, or the replacement of the hot water heater. The T valve here in line is to release the air locked in the system. And that's on that closed loop system, utilizing the demand recirculating pump. And it works. And when we installed this, we had no issues at all with air in the line. And in fact, I believe Larry was telling me now you can buy that component. Somebody's selling it as a one piece. Another lesson learned with the heat pump hot water heater was we had some egg smell coming from it. It was just from the water. And it's the sacrificial anode, that's right here in what we're showing you right here. And we had to replace it to get rid of that rotten egg smell. And it wasn't like something that you would check every 3 years or it would happen. It just happened. Sometimes it happened, within the first 6 months, within the 1-year warranty. but that was the answer. So again, knowing the issue and not having to hop around it, it's just the simplicity of the design. Other points is letting the homeowner understand the operation of the heat pump water heater. And that's a big one. So include this in your homeowner's manual, because they need to know what efficiency mode is, hybrid mode is. They need to know when it's running just on the heat pump, or when it's can match it with the element when necessary. And Marcus will go into that a little bit further. In vacation mode, on all electric mode, which you really never want to do, but depending on your zone and where you're operating, we found here in zone 4 that the efficiency mode and maybe going to the hybrid mode in the cold of the winter is where the people are. And so we've had over 100 installs through the buildings of my homes, and only 2 had to be replaced under warranty since 2016. But it was an argument. In other words, I'm calling the plumber, and the homeowner's calling another company, and there are other companies say, yeah, we can fix this, but the fact was that it was not, I don't know if they could have fixed it, because we had things that were happening that we would have a code that would read condensation line clogged, and it wasn't clogged. We just had issues with it. And so we had to replace those 2, and that was less than 3%. And air and recirculating line until redesigned. That was the other issue. And we took care of that with that design that I showed you. So it's worked well with us. The homeowners that in zone 4 has been happy with the product. And then the must-haves, when we design our homes, one of the must-haves that we're looking for is structured plumbing. We want, and you can see in this drawing, this picture here, that we've got lines going to service on the main loop within 5 foot of the fixtures. So it's easier to get that hot water quicker. And all the lines are insulated. Before, we never had to insulate lines. And we did it because this was the right way to do it. Now code tells everybody that you've got to insulate the hot water lines. At least that's in Virginia. That's happened now over the last 2 years. And then the on-demand recirculating pump. And we'll talk about that a little bit more, Larry will. And then the expansion tank, and that's because it's a closed loop system to handle the thermal expansion of water as it heats up. We make that standard. A lot of times you'll see people installing them, but they're not there. So I want to close with the Steve Hawkins' final book title, Brief Answers to the Big Questions. So information discussed today on the heat pump water heater is brief, but it's to the point. Your feedback today will help us shape our EBA presentation that will answer your questions in detail. And I'd like to thank you all for giving me this time to talk about it, and move from myself to Marcus to continue a little bit more in-depth story. And please remember the same. Your feedback today will help shape our EBA presentation, our live EBA presentation. And thank you.
Thank you, Jay. Good afternoon, everybody. I'm Marcus Linger, and as I hope you can see my presentation at this point.
Yes.
Looks good.
Good. Good. Thank you. I'm a water physicist, so I've been in water and wastewater for the better part of 30 years. And among those things, also a lot of times I had to measure systems, I had to measure flow, I had to measure temperatures, and I had to measure a lot of things that you would have to measure with a water heater. So I was approached about 1.5 years ago by a large utility here in Southern California, as well as some expert that said they had some issues measuring a hot water heater. It's not as simple as just putting a sensor on. There's a little bit more involved in it. So for the last 2 years, we've been analyzing heat pump water heater performance, specifically looking at different scenarios. And let me see here, sorry. Let's see, next. So we want to look at the operating principle. Jay touched a little bit on it. And there's one thing that I always want to remember, people, that's often greatly misunderstood. There is no such thing as cold. Cold is an absence of heat. You know, it's just heat goes up, and then if you have less heat, that's basically cold. So basically what you have to do in a heat pump, what a heat pump does is you move the heat from one point to the other. So you move the heat where you don't need it to where you need it. And a heat pump actually can effectively do this both ways. So for an example, if you were to run an air conditioner, you would be able to move the heat from inside the home outside. That's what an air conditioner does. A heat pump has a little valve in it that will reverse the condenser, and it allows you to do the exact opposite. So you could basically move heat from the outside into the home. So that's in essence what a heat pump does. It does take a lot of energy to create heat, and it takes a heck of a lot less energy to actually move heat. And this is really where we get a lot of efficiency with the heat pump. It doesn't actually create heat, it just moves it. So the heat is exchanged via air ducting. Jay kind of pointed that out. And that means you have to do very special attention to air ducting. You have to have an effective way to move that heat in and out, depending which mode you're running. And if you don't do it, they will not work well at all, and they will be not nearly as efficient as they could be. They may even end up being worse efficient than just a pure electric. One of the things that, of course, we found out that measurement and monitoring such a system becomes vital. It's worth it to optimize the system. It's worth it to monitor it. And Larry will go a little bit into how that's done on his level. We've been doing it as well. So we came up with quite a bit of information on that. So typically what we do with a measurement setup is, this is a very typical measurement setup. So you can see we have 5 flow sensors, we got 8 temperature sensors and 1 humidity sensor. And this is how we start actually looking at measuring all the hot water heater performance and figuring out, you know, how efficient are they? When should they actually be turned on? When they should be turned off? When do we start having heating elements known as resistive electric heating elements? And when can the heat pump just do it? And what are the scenarios where the heat pump could have done it, but for some reason, either the user overrode it or whatever, the resistive came on. So that's one of the things. It actually turned out remarkably complicated to measure that, unnecessarily so. Just a lot of proprietary stuff out there, a lot of stuff that was difficult to install, difficult to maintain. You had to go run there just to get a USB stick in. So in other frustration, we actually decided to just build our own system. And so we're calling it the Building Performance Analyzer. And so here you see a system on the left, that's what it looks like, the master system to measure all the things. You can also see the recirc pump and the act controller there. On the right, you see another system that all wirelessly talks. In the middle, you have this little briefcase that analyzes completely the efficiency, stores all the data, and you can connect remotely to. So what did we learn? So here's one scenario. We kind of looked over it. You see the dates here. It's not quite a year. We found out that resistive is used a lot. That's the blue part, and the heat pump only is used. That would be the orange-red part. So we're kind of figuring out that in this particular scenario, 92 gallons per day is the water usage. That is a homeless shelter that has roughly 25 people, give or take, living there in their shower and prepare their food. So you can see that a lot of times the resistive actually is doing all the heavy lifting. We have some days here where it's all orange, and that's when just the heat pump did it. So now we're starting to look a little bit here at the the heat pump water heaters. And so when you look here at the lower bit, kind of that red squirrel, that's really the energy usage of your heat pump. And then the green, the much larger one, if you look at the power, that's your resistive. So power consumption, the resistive element is under magnitude of, it's like 15 times more than a heat pump. So that's a significant, difference. Now, that doesn't necessarily translate into savings, depending how you run this thing. But if you were just to turn off the resistive and just run with heat pump, then yes, you would use 15 times less power. You may have to wait longer for the water to become hot. So next thing that we're going is, I think, sorry, I might have missed it. Yeah, so the other thing that I wanted to show you is, and I wanted to switch here real quick, if I can, to a different screen, because I have actually some live data that I wanted to show. Sorry, I am going over here. I want to show you actually some live data, so and how we determine whether something is actually efficient or not. And so here we are looking at, hopefully you can see this.
Yes.
So this is a, hopefully you can see it. This is a system that helps us. Again, this is this briefcase that I showed, where we have different ways to look at the data. So we can zoom in and we can actually start looking at, like, what's the temperature range? What do we look at? We can actually start looking at flow data. So this is all live data that we're pulling and building. So this is something that helps us, even if you just have to go in for a week and start looking at how efficient is the entire setup, how efficient is the water heater, do we get the savings that we need? So this is a very simple system to help you determine that. So let me go back to my presentation. Sorry about that. And here, let me share again. Okay. So to sum it up a little bit here, what I said, if you install it right and you operate it right, it can use up to 15 times less energy. So that's, of course, huge. Setting up the proper mode, as Jay actually pointed out, is absolutely vital. So if you put it in the wrong mode, you're not going to get any savings at all. And beware of user overrides. And this is something that with a measurement system, we can actually see when the user is starting to do something. And this can blow the whole caboodle. If he goes in and wife tells him, water is cold, and he goes in and just cranks up the temperature or sets a different mode and forgets about it, all your efficiency is out the window, all your saving is out the window. So it really comes down again to Jay. What Jay said is you got to tell your customer, explain it, take that extra time, walk him through it and say, hey, this needs to be set right, or it's not going to do what it needs to be doing. What we found really is the recirculation pump in a loop is really the Achilles heels. It kind of sits there and it just either runs or it's on a timer. And depending how you do it, it can eat up to 80% of your heat energy just going in a circle. Nobody ever uses it, just being wasted. And that's really where Larry's system actually takes that out and make sure that is being on demand. Only when you need hot water is actually energy being used. The one thing about resistive heat, which are the electric heating elements, is they are a lot faster. So they heat much faster. And that's why if you're in hybrid mode, if the controller of your hot water heater or heat pump hot water heater thinks you need more hot water, they may just turn on the resistive heating element depending on your mode, and that's when your efficiency really goes out the window. Hot pump water heaters, give or take, depending on the sizing, can heat about 20 gallons per hour. That's about their max capacity. So they're not slow, but they're not as fast as resistive heat elements. And as you can see here in the recirc pump, and as it goes a little bit back to the Achilles heel of the recirc pump, a lot of energy, as you can see here with the thermal camera, is actually lost in the recirc pump. And controlling the recirc pump is part of a proper strategy. So I want to talk just real quick, because it's being overlooked, the impact on off-grid installation. So if you have anything that runs off a battery pack or runs off solar, or the owner wants to reduce its electricity and utility bill, then there's special things that we have to look at. So a heat pump water heater, this particular one, let's say an 80 gallon model, uses only about 300 watts of power. So that's very little. That's actually very easy power to generate. Typically one panel can do that, a single panel. If you look at the power usage of a resistive heating element or an electrical heating element, that's 4,400 watt. And that's where I kind of went in, is the 15 times more. That's a lot of juice, and when they start turning on that initial surge that before the element gets hot is even more power. So if you're off grid, that's a huge load on your battery. That'll just really hit your battery hard, start draining it almost instantly. And as I said, when you start measuring the heat pump water, it heats about 20 gallons per hour. So what you need to do is put a little bit of strategy together. How much water do they need, and how should I set this? So with the if you have a heat pump water heater just in heat pump mode, and you know it's only 20 gallons per hour, but that works with a little bit of management, then you can get away with a much smaller battery pack. Here in California, we don't really get incentive for net metering anymore. It stopped about 2 weeks ago, and you get paid almost nothing. They really want you to push towards having a battery pack in your home and store the energy that you make during the day with solar or wind or whatever it may be, and use it at night. And as we all know, the water heater typically comes on at night. You want to have hot water ready in the morning. Some people take a shower in the evening, so it depends a little bit on all of it. So having said that, and having looked at the solar panels that you need and the battery that you need, the savings can be actually greater than $10,000 if you go with a hot pump water heater. You need a lot less battery. That's really it. Thank you, and I give it over to Larry.
Great, thanks, Marcus.
You're welcome.
Larry, I'll have you unmute. Maybe we'll take a quick question when we get Larry unmuted. Marcus, I think it's fascinating what's going on in California, particularly with the net metering and people moving, and moving to battery storage. And I think you bring up an incredible point there. Have you compared this at all to gas equivalent? So I think the question is, can a heat pump water heater compete with a tankless gas heater, or will it always be expensive? And that particular question is in reference to the LA market.
A very good question. We're about to do a rather large project with the Southern California Gas Company here to actually compare that directly. I have some preliminary data. I have a small place in Palm Springs, and that's exactly what we have, is just an instant water heater that runs on gas. So I have some data that we're comparing. There'll be absolutely a DEBA conference in the fall. We're going to talk specifically about that. We will have the data, but that's something that, as you can imagine, with the decarbonization, the gas company wants to have this done on pure science. And some of the data we just don't really have. We need to really collect it and start analyzing it. But the bottom line is that it's going to be tough to beat a gas water heater in its speed. That's for sure. I mean, the heat pumps are extremely efficient, but they're comparatively slow. You can plan around that, but it's still, they're much slower. There's just no two buts about it. And it depends a little bit on the inside-outside temperature. As heat pumps become more efficient, if there's a greater temperature difference, they're not always having the same efficiency because it really depends on the weather.
Right. So you bring up an interesting point. I think you hear anecdotally people say, well, you need to oversize your heat pump. How much does sizing or oversizing your storage with hybrid heat pumps affect your energy use of a heat pump utilization versus electric resistance utilization? And so if people should have put in a 50 and put in a 65, does that help them stay in heat pump mode more often?
Yes, it does. I mean, we have actually some data. We have some big Sanco units that we use now. Those are the split systems. They're just larger heat pumps. That's why we use them. And we're absolutely seeing that. It depends a little bit how fast do they want hot water and how much, they're willing, to wait for that. In general, for an example of the research project that we run for 1.5 years, we found out that the heat pump would have actually absolutely been able to do that. But for some reason it didn't. The controller kicked in when it didn't really need to. And one of the problems that we're looking at is a water heater can't, as advanced as a water heater may be, it can't really make all these decisions because it has to rely on some sensors that are going to be outside. It has to look at flow. It has to look at temperatures of the loop coming in and coming out. So this really goes back to not only structural plumbing, but you really have to look at hot water as a system. It's an entire system where, yes, the water heater is a major part of it, but you can waste it a lot on plumbing. You can waste, as I said, 85% on not controlling your recirc pump, which unless you have a Larry Acker system, it just kind of sits there and wastes a lot of energy. And a water heater can't control that necessarily. So it really becomes a point where you have to look at the whole thing and how they interact. It needs to be better controlled to be more efficient. It's certainly what we learned.
So, Marcus, in your testing, did you measure the energy consumption prior to the recirc pump versus, so did you control for the recirc pump in that? And I think that this guest is saying whenever they see a heat pump water heater with a recirc pump, it uses much more energy. That kind of came out in the data, correct?
Yes, it is. Especially if you use a heat pump water heater, you need to control that recirc pump. You need to get some control mechanism in place. It's absolutely vital. It has a little bit to do also how temperatures measured inside these water heaters. They're not really set up for that. So there's nothing wrong with the water heater itself. Again, the water heater itself will not be able to get all the data, the temperature readings and the flow readings it actually needs to do this efficient. And so that's where, with the slide that I showed a little bit, the typical system that we have, that allows you to control it much better. And yes, we had 80% reduction in energy usage if you control it right. Yeah.
Great. Well, with that thought, let's turn it over to Larry to talk about how to control that on-demand system, which can use, what did you say, Marcus? 15 times the energy?
No, that's the heat pump water heater is 15 times, the compressor in there uses 15 times less energy or electricity than the resistive water heater. But what happens is that what we learned is up to 80% of the entire energy that you use to heat the water, which is, if you don't have an EV, one of the largest energy consumers in your home, heating water takes a lot of energy. Up to 80% can be wasted in the recirc loop, just waiting for somebody to use it. And so the water heater needs to keep heating that, and it literally just goes in a loop. And so that's where the plumbing comes in. That's where the insulation comes in. And with the system that Larry has, and he'll explain it to you, you can reduce that energy loss dramatically.
Great. Larry, we'll turn it over to you. And unfortunately, I'm not hearing your audio right now, Larry. No audio. Larry, do you want to try sharing your presentation?
I can share if I need to, but we can't hear him.
Yeah, otherwise, Nancy, why don't you share? And then Larry, worst case, will go to phone line for your audio. And we'll do the old technology workaround. Let's handle a couple questions when we get that figured out. And maybe this is a good question for Marcus and for Jay. Are heat pump energy efficiency ratings accurate?
And
that's from an anonymous attendee.
Yeah, of course it is. They have a chance to be. I think that Jay, you can talk probably more about it. It really depends how they've been installed. As we all know, it depends on the plumber and how he puts it in. And there's so many variables that can eat away at that. You know, they've been tested in the lab under certain, you know, circumstances, and they get a rating. But if you a little bit go into Larson research, the incredible shrinking room, you might want to look that up. You'll see now that they're actually, they can be more efficient than advertised, but there's lots of variables, especially how being installed, how being duct. Jay, I'm sure you know quite a bit about that.
What we found through the 100+ that we've put in is that they work. Very little resistance from the homeowners. Some issues that we've had with them, but we've always coupled them with structured plumbing, shortening that run to the fixtures. We've also helped its way by insulating the hot line, and then the on-demand hot water. So that's added features. And our HERS reports on our homes, our total homes, have really, in fact, been higher than what the actual operating costs of our homes are. We found that we guarantee the total electric bill in a home to be no more than $1.50 a day averaged over the year. And we've never had to pay out on that. And that was probably, it was, you know, right there at the HERS numbers. And so we always came in, and it could be because it may not be the efficiency number on the heat pump hot water heater, but we use a variable speed air compressor. Again, that's something else that's hard to touch, but we know the numbers that we're reading and we're using for the HERS report works. The efficiency, I cannot, you know, that would be more of a Marcus answer, but to me, the system works. And our customers in zone 4 are happy with it.
If a heat pump is installed correctly and operated correctly,
Yes,
it is a game changer when it comes to energy usage. Just no 15 times less. I mean, we're not talking 10 or 20% less. We're talking 15 times less. That is huge.
Yeah. And Marcus, can you talk about that? That's often related to us in terms of coefficient of performance data. And can you compare and contrast that with any gas unit?
Well, again, sometimes it has to do with speed. You know, like the customer opens the faucet and he wants hot water. And, you know, there's something to be said, especially here in California, that like if you wait too long for the hot water, you start wasting a lot of water, which isn't good either. And actually Larry's system is something that prevents that. But, you know, if you get used to the fact that you have to plan a little bit, you know, you can't have like 5 teenagers all taking a shower in a row. That won't work. You know, the last 2, I'm not going to have, you know, hot water. I think the efficiency is absolutely there. The speed isn't there. That's kind of what we found out, is you need to either have a bigger tank or you have to have some other control strategy. You know, gas water heaters are pretty easy. You turn them on, you have water fast, hot water fast. So there's not a lot of control strategy that's needed. With heat pump water heaters, it's different. They need a little bit more control and a little better install. There needs to be some thought that needs to go in. But if they're done right, as I said, you won't look back.
And I think on the question side that we had on the COP, you can have a 98% efficient hot water gas fired unit.
Yes.
We often are seeing coefficients of performance on heat pump water heaters now that are 4, 4.5, 3.5, somewhere in that 3.5 to 4, which is 450% more efficient. So every dollar of energy you put in, you get 4.5 out. Every dollar you put into gas, you get 98 out. I think another question we have here is, will a heat pump water heater compete with the power vented gas unit with tank? And yeah, absolutely it will. But your point, Marcus, is we need to think about the water as a system, compete from the speed perspective, right?
Right.
From a pure energy and cost perspective, it's less. From a speed perspective, it has to be managed thoughtfully.
It needs to be managed, but then people that are off grid or off solar or even with battery packs, they kind of know that, you can't run the toaster oven, the dishwasher and iron your clothes at the same time, the system will collapse. So you have to, have some sort of a power management. And, there's a lot of technology out there that's starting to address that. And so I think we need to look a little bit, we need smarter homes. We need components within the home to start talking to each other. That's kind of where things are really going with the smarter home. I'm not necessarily talking about an S thermostat and all of that, which they're all nice, but there needs to be some core systems in the home that need to be able to communicate each other, and then you can manage that quite effectively so that in the back, it's not really something the consumer has to worry about or bother about. He's just looking at savings. But again, we learned that if you do a heat pump water heater right, you install it right, you dimension it right, you size it right, you do the plumbing right, then you can even have higher COP, you can even have higher efficiency, because it's always somewhere between when does the resistive kick in? How much will a manufacturer let the customer suffer with not having enough water, but before he says, okay, I'm just going to kick in the resistive heater because, they don't want their brand to go bad, which is all absolutely understandable. So I think somewhere you can go and say, if I just do pure heat pump water heating mode, and I know it's going to take a little bit longer and I'm going to plan around it, you'll see incredible savings.
Great. Larry, do we have you up on audio?
No.
Not quite yet. So Jay, here's a question for you. In a multifamily project, it's typical for traditional hot water heater to be put in a small closet because of the limited area. However, with a heat pump water heater, it seems to need to be in an open room that is at least 90 square feet, depending for air circulation, ? I'm in the Northwestern United States. What would be your advice? And Dr. Langer, you mentioned the incredible shrinking room, but Jay, I really liked your analogy of putting it in the laundry room and actually doing some heat recapture off of the heat pump water or heat pump dryer. Can you talk about that a little bit, Jay?
Well, I'm going through this myself with townhouses right now, and it's trying to get a zero energy ready townhouse. If you can do it right with the tax credits, actually you can move it over to single family and you can get up to $5,000 in tax credits for it. It's something that it's going to change starting with your requirements starting 2024. So if you get a building permit this year and you finish it, or you sell it or lease it the following year, the IRS will not allow you to take that credit. So you have to be able to take it within either this year, but trying to get to that point, I'm struggling with it myself. So what I found is that we put a shed, basically a storage shed, or it could be a drop off for Amazon, whatever you want to name it. And then we can either condition it or we can and vent it to the outside to get it into that smaller area. But it's hard for them to be able to find something within, because if you're looking at a townhouse or an apartment that's 900, 1,000 square feet, 800 square feet, there's not going to be a place for it. You've got to think outside of the box. And that's exactly, what we came up with. But it's whether you want to meet Energy Star or whether you want to get down to the zero energy ready home. With Energy Star, then after going back and forth through it, it looks like to me and how many bathrooms do you have? We have a bathroom and a half in the size of a unit. So it's an on-demand hot water. Is the first answer. The second answer, if you're looking for that tax credit, then you look at an outdoor shed that can be some storage and allow you to have a space, that backs up right to the kitchen. Because now you've kind of got it where you need to be. Because usually the kitchen, the bathrooms are right on upstairs, the half bath downstairs, it's all right there in that configuration, and very, very efficient to operate.
Right. So I think what I hear you saying in answer to Jake's question is you can't place it in a small closet like a traditional tank. You have to be thoughtful. You either need to vent it. It needs access to a volume of air to be able to extract the BTUs to run very, very efficiently. But I think in Marine Zone 4, you always have that option of the garage, do you not, Jay?
You do.
Yeah.
Yeah, you
This one
do.
does- yeah.
And then also too, depending on the size of that townhouse, if it can use less than 50 gallons, then you can reduce the cubic feet required down to 400.
Right.
So, because you're only feeding a bath and a half and you get a short run. It's achievable, but it is definitely a challenge in design. And that's what we're going through right now.
Yeah. Larry, how are we doing on audio?
No.
Jay or Dr. Langer, can either of you give Larry's slides?
I can try. I mean, probably
Yeah,
Jay,
we
you
can
know it a little
try.
bit better than me. We
Yeah.
can both try.
Yeah,
let's
we
go.
know what it is.
Yeah, let's go through the slides.
Let's go through. Just click next slide for us and we'll control them from this side. But we now have the Dr. Langer and Dr. Epstein
No
presenting
doctor.
Larry's slides. Let me start off Larry's slides with a question. I think it's a good one. Will all heat pump manufacturers allow demand recirculation or the ACT demand system on their heat pump water heaters? And then take us through the presentation.
Okay.
That's a good.
Marcus,
Go ahead.
you want to answer that question? What I see, it hasn't been a problem here on the East Coast.
And I don't think why it would make a difference to them, why
No.
they have any input to it. Absolutely. I mean, if a manufacturer would tell me you can't do that, I would press really hard. Why?
I mean, you're receiving water. It's the channel of the water coming through. I mean,
Right.
they're not guaranteeing the efficiency based on their energy guide at this point. That's up to the warranty. In other words, that homeowner's warranty, what we're doing with it. So I don't see where that would make a difference to the manufacturer.
It shouldn't, because it's really just a method to control the recirc pump. And you kind of, the best way to explain it is, and Larry, is of course way better, is you kind of prime the system, and then so when you need it, it's like it runs in a circle, so it doesn't waste water and it doesn't waste the energy till you have that temperature that you need. And so that's why it's called on demand. When that water needs, you can either press a button or have some other mechanism, motion detection or whatever it may be, and it'll literally prime the hot water. Now in scenarios like this, and what we used, we always use them when we do our tests. We put them in, we turn them off to demonstrate how much they actually save. Turn them back on. We kind of have the industrial version of it. They don't actually have a demand button. Well, they do have one at the controller itself, but typically they just start monitoring the water usage, and they can detect a demand for it, and basically, if you want to prime your loop.
Yeah, and to clarify, whether it's gas, whether it's electric, whether it's heat pump, it's not going to avoid any of the warranties. And the byproduct is simple. It's very simple. And the reason I got excited about it is that from the green aspect, we're saving up to 8,000 to 10,000 gallons of water a year by not watching it go down the drain and waiting for it to get hot.
Mm-hmm.
And that's a big piece of our marketing. And and I said it in my presentation, it's an instant savings. First of all, in Williamsburg, Virginia, the homeowner we write a letter, stating that it was installed. They get a $50 rebate from the water company. Which shows that the water companies are looking for it because it reduces their carbon print of having to processing less water going down the drain. And it's just a win-win for the community itself. But let's go to the next slide. Who's pushing buttons on the slides?
Nancy, can you go ahead one, please?
Okay.
Great.
And what you're looking at is the activating your demand control pump, and it's quick and easy. And basically, you've got two different designs. You've got the one on the right, or the circle, and this is the new pieces that he's starting to add in now. We're actually showcasing it on a Panasonic Summit home that we're building in Williamsburg. Go to the next slide. And Marcus, you can go through the loop.
Yeah, sure. I don't know if you can hear me. No, sorry, I thought it was Larry because I told him to call in. So basically what we have here is, again, the return loop. We have the hot water heater down to the left. I can't show you the mouse, so you kind of have to follow it. Then we have the trunks and the twigs, of course. And we have, so this is your typical loop that we all know so well. And so we have thermal sensors in one or two locations. So we can have one just before the hot water heater coming in on the left. We can have one on the upper right here. And they will actually measure delta temperatures. So they're measuring a temperature difference. There's connecting to audio.
That's
We'll
Larry.
see.
Larry?
He's on mute.
You're still on mute, Larry.
Is that any better? Can
Hey,
Yeah.
Wow.
Okay, Larry,
He's
take this thing
alive.
over.
well, hey, you guys
Undo the damage.
Larry, go before we lose you. Go.
Well, I really appreciate both you guys doing my. I got a computer problem here and where I got my website. Anyway, I do want to add before we get any further in this that this is a preliminary of what we're going to be doing at the show and the conference in Salt Lake City for a webinar. We're going to get into a lot more details. And I know, Marcus, you've got tests that you're going to bring in that are going to be available. Jay, I know you've got some tests that are going to come in and going to be available. So we're going to be in a question answer period in that area as well. So keep in mind that this is just a preliminary of what we're going to be doing. But what I've got here on the slides are two slides. One is if you don't have a dedicated return line, we can still activate the water heater by using the cold water as a return line. And the sensors can be put at the farthest fixture. So the water only gets hot to the farthest fixture in a non-return line, so we call standard plumbing. In a dedicated return line, we can put it either put the pump and electronics at the water heater or at the last fixture. If you want to go to the next slide or this real quick, I'll get through this. Yeah, that our new technology is Bluetooth technology. So everything can be loaded onto an app on a free app that we supply. So you can have controls anywhere in the home. You can activate the system when you want to. Could you get on the next slide? That's a scheduling. On your cell phone, you can actually put the schedules of when you actually want that water to be turned on. The controls are set in such a way that if hot water is already in the line, it won't turn the pump on because you already got hot water, but you can schedule it. So if I get up approximately 8 o'clock in the morning, it's automatically going to supply hot water to that location. If I were to activate the system 10 minutes later, it's not going to go on because hot water is already in the line. Go on to the next slide. This our new controls by Bluetooth have a defreeze in it. So if you're in a market area where the water pipes have a tendency to freeze, then you can actually preset the temperature on your sensor on our controls to be able to turn the pump on automatically if the temperature drops below, let's say 37 or 38 degrees, whatever you want to set that defreeze temperature at. So we've got a number of features and functions on the new Bluetooth app that anybody in the home that logs onto that app will be able to do the same thing in the app. So we could have 5 people in the phone that all have cell phones, and they'll be able to activate the system and actually set their times, whatever they want to do it. So virtually, and you can go on to the next slide. These are some of the operations we currently have on new home operations. One is a LED decor switch, and the other is an LED light. And they only go on when the pump is actually running. So when you activate the system, that light indicates that pump is now running. You're going to have hot water in a few seconds. Next slide. This is motion sensors that operate on the same principle, with the exception they only operate if there's enough heat, if there's enough weight, and if there's enough height, meaning anything under 4 feet will not activate the system. So dogs or animals or kids won't activate it. And because the sensors are set on a timer type base, meaning they lock out, meaning as soon as they send one signal, they'll go into lockout. So it's not a constant flow of a motion sensor. And we design these, we make them all in-house. And consequently, it's an American-made product. We've developed it and designed it and built it here in America. So the next slide. We've been doing this since 1992. We invented the concept of on-demand control systems. So any variation that you see in the market between 1992 and now is our invention. It's just a matter of being able to, we're ahead of the game, meaning that we have activation and the ability to do things within our controls that nobody else has at this point. Because part of it is patented, the other part is just technology that we do that nobody else does. So next slide. There isn't a next slide. Okay. Basically, the slide that I wanted to show is exactly what Jay had said previously, and that is that it's just a matter of technology. Heat pump water heaters literally were invented in heat pumps were invented in 1948, but they didn't become popular until Rude came out with them in the late 1800s and almost 1900. Stabile Eltron was the first one to really commercialize a heat pump water heaters, and that was in 1976. I actually had a heat pump water heater. I was a general contractor in my own home, 3,500 square feet on a lake on the Ozarks. And I actually had a heat pump water heater put into that home in 1976. And I had 5 years of experience of how they operate. Those days, they didn't operate all that effectively, but it was very efficient to operate a family of 4 in a 3,500 square foot house. So if you do it correctly, like Jay and Marcus are saying, it will be efficient. If you don't do it correctly, you're going to have a resistant water heater that's going to be very costly to the homeowner. That's the end of my conversation, and I apologize for not being involved to begin with. Again, Nancy and Aaron, I really appreciate your time. We will all see you at the conference in Salt Lake City, and we will have another party involved in our section. There'll be a builder that has been building for some 40 years, the last 25 years off grid. He builds multiple homes, and he's been using heat pump water heaters for a long time, and he's used them with solar. So that's one of the areas that we'll probably want to get into with some of the information that Marcus has. So that's the end of my conversation.
Great. Let's do a couple questions here just to wrap up. I know we're a little bit over time. We apologize for the technical difficulties, but they happen. Larry, will Bluetooth qualify under some state codes where activation needs to be at all areas with the fixture, 20 feet from the heat source, for example? California is writing their code like this.
Well, Bluetooth, we went Bluetooth instead of Wi-Fi for one good reason, because Wi-Fi is not a very secure area to go to. Bluetooth is encapsulated within a certain area. So the footprint of a home, Bluetooth would be very, very secure. The code requirements that they have on 20 feet or 50 feet, and there used to be 10 seconds of getting hot water to any fixture. We can't control the way the codes go or the way you plumb the house. And that's what Jay was saying. You've got to structure your home. So you've got what they call structured plumbing. You've got three sections that are really critical in supplying hot water. One is a water heating system. The other one is a distribution system. And the other is the faucet that opens or closes to make that hot water come out. And when you put in low flow fixtures, you've created a problem for the other two, because you've slowed down the ability for the hot water to arrive at the fixture. And it doesn't affect the water heater. Water heater works fine, but it will affect it in the distribution side because you just can't get the hot water through the pipe fast enough, which is one of the reasons we developed what we did, because we can move the water regardless of your fixtures. We can move the water at a speed that allows that water to flow what we call a very short delta T between your ambient temperature and 120 degrees. So when you turn your faucet on, you're going to have hot water. That's simple.
Great. Dr. Langer, question for you. Thoughts about using a recirc system versus setting a higher tank set point?
That's an interesting one. It would depend a little bit on the size of the house, I would say. Look, again, how the plumbing is, what are the plumbing runs, how many people are in the house. Typically, what we learned is when you have a section of pipe that holds 1 gallon of water, and the water is cold, and you feed hot water on one side, then you reckon after a gallon of hot water going through that pipe, you'll have hot water on the other pipe. That is not so. It takes a little bit more than 2 gallons. And that's just because the viscosity of the water with the different temperatures is as such that they don't mix well. And so it's just really the physics of water that hotter isn't necessarily better. Flow is actually something that water really likes. So there are certainly arguments that can be made for recirculation loop that makes a little bit more sense than just simply having a higher temperature. Higher temperature, of course, it depends how well insulated the water heater tank is, and again, how often people will use it. I know there's been some push of forgetting about the loops because they are too energy inefficient. But I think if you control the loop proper, then that, at least for now, for what I have seen, would be probably the smarter way.
Dr. Langer, there's some new models of heat pump water heaters that are coming out that actually have a thermostatic mixing valve. So they're setting the water temp higher to have that meet that high peak demand, but then mixing it back down to 120 degrees to send it through the system. Have you tested do you have any data on that type of an installation yet?
Yeah, I believe you're talking about the GE system, if I'm correct. Yeah, very interesting. I have not seen the data yet. I haven't, I've looked at the brochures, I looked at the data. I had a conversation with somebody within GE, and I think it actually does address one of the issues that we're having. It's definitely an interesting concept. There's no question about it, and it will address some issues that arise. Yeah. I haven't seen definite data yet in the field. As I said, we've been looking just at regular 80-gallon water heaters. We've been working a lot with the Reams, and now we're doing the Sankos, which are larger and more expensive. And we're just looking basically, what's the efficiency of having a larger heat pump, heat and water. And in this particular scenario that we're doing right now, we don't even have any resistive. So we're doing this simply purely with heat pump because we want to see, how well does it do. But at the end of the day, the biggest piece of data is really asking the homeowner, hey, how much longer did you have to wait? And, is it too long, or are you skipping showers and going out smelly because it takes too long? These type of things, right? And so there's not necessarily a sensor for that that I know of.
Yeah. I mean, I can tell people from my experience, and Jay, you've experienced this technology, and Larry, you have. I mean, I have my heat pump water heater. I have it set on heat pump only mode. Now we only have 2 of us in the house, but it is always fine for the 2 of us. That's just my personal anecdote. Larry, this is probably a question for you. Although I appreciate your prejudice in answering this ahead of time. Will any timer or aquastat work with the heat pump water heater, or only the act demand system?
Well, that's a good question. The problem with aquastats or timer systems, you're actually going to be activating your heat pump when you're not having a use for hot water. And that's exactly what both Jay and Marcus have pointed out. You don't want to be running that heat pump unless you have to. That's the problem with anything that circulates or actually allows the water to flow when there's no use for it. There's 2 times a pump should never run, and that is if there's no demand for hot water, no use for hot water, or if hot water is already there. If hot water is already there, then you certainly don't need a pump running. But the key with any water heater, whether it be heat pump or whatever, the efficiency of the water heater is going to be judged and actually marketed by the ability of the circulation of that water to your fixtures. So the demand of the hot water by the user really are the ones that are going to allow whether that water heater is going to be more efficient or not. That's why structured plumbing is so critical. You need to plumb your homes so you can get hot water when you turn your faucet on within 3 to 5 seconds. And if you can do that, which I've done on several occasions, building homes, it's really the key of energy savings for the water heater and everything else, water, sewage, processing, everything else, is the ability to not use that hot water more than you need to.
Right. It's the energy penalty that you're going to pay.
Exactly.
So final question. Is there a preferred activation method for act demand controls? Is it the app? Is it Bluetooth? Is it motion? Is it push button? What are you seeing working the best? Jay, maybe you want to come in here with your experience in deploying these as well.
Let me start by saying, Aaron, that's a very good question. Thanks for asking that. The people that have actually, the builders that have actually put in the wired system that have the LED light on it, the folks actually love it. People that have never used it and never used any type of activation don't want, they feel uncomfortable saying, oh, well, I have to go hit a button or something like that. But those are the people that have never used them. A lot of the folks like to use motion sensors. That's why we developed one that was efficient. You don't want a motion sensor that's an open face motion sensor because it'll turn it on quite frequently. The way we've designed ours, you got 2 scenarios. One is the motion sensor only works under certain condition. And secondly, the electronics keep the motion sensor on us because even if it did go on and hot water is already there, it won't allow the pump to turn on. So it's a matter of what you want to do is being compatible with the systems that you're using, whether it be water heating, distribution, activation, whatever. But the answer is we get people liking both. It just depends on their habits.
And our buyers, we're in a retirement community. So the app, they're not interested in the app. They're really interested in the push button. And then all of a sudden you realize you're not waiting for the light to come on. You're brushing your teeth and you know when to get into the shower. It becomes secondhand. And once that task, you adapt to that task or it adapts to you. But it's simply what we install or the push button.
But Aaron, the way the future, Aaron, is actually going to be electronics. So we see the younger generation in the 20s and 30s and even 40s that like the idea. They carry their cell phone with them everywhere. So it's like carrying your activator with you. We use them in our own bedroom. We have them to, as an alarm clock. We use them for everything. So the form of a cell phone, whether it be a watch or whatever the new technology is going to be, we want to be on top of that ability to be able to allow whoever buys our product to be able to adapt it to their habits or what they like. And frankly, we find the younger people really like the cell phone concept.
That's a
I
great
agree
point.
with them. My wife doesn't want me to have a phone in the bedroom, though. That's my age group.
Yeah.
It's also mine, Jay.
Yours.
Okay,
I
so
always said, when when you made it is if you don't need to sing anymore.
Yeah.
no, I think
They
it's
can find you if they need you.
I think it's a great point of know your audience of who you're building,
Yes.
and that I think the younger people are going to want an app potentially, and some of the rest of us you're fine with pushing a button in the kitchen or in the bathroom.
Well, one of the things with the app also that it allows you to integrate into actually a home. So the Bluetooth, this is a way to talk to that controller. So app is certainly one of the ways. So it allows you to integrate it. So if you have a system in the home that has occupancy sensors and there's a lot of interesting technology that's very inexpensive that actually measures your heartbeat and your breathing. Those are the nanometer, the little radars. If in the future, if you have a home that can do that, then it's very easy to implement that particular system, because whether an app sends the instructions or whether an intelligent home sends the instructions, at the end of the day, hey, I need hot water, and the system makes it.
And Aaron, before we close out, Marcus, I have a question for the live time. And that is future refrigerants, maybe propane, more efficient
Yes.
than current refrigerants. Don't have to answer it today but it could be a discussion point.
When I was down in San Diego like 2 months ago, the Hot Air and Hot Water Forum, there was somebody from Oak Ridge National Laboratory that talks about, like propane is the perfect refrigerant if it weren't so darn flammable. So I think it's somewhere at I think it makes people nervous to use propane and then run it to a compressor. It's certainly somewhat unsettling that works in a home, but on the other hand, you of course can do that quite safely. There's also some interesting stuff that's going on with acoustics, as you may heard. There's refrigerators now in Germany that actually use sound to cool. And they actually also had a prototype there that they did a test with it. I think this is an area with massive research going on, and so there's a lot of changes, and so we're moving forward to looking at maybe even have one heat pump to do all the things in a home. So that would be the really efficient way. How to do that? Well, people are trying to wrap their head around it, but it's a very active area, and we're starting to realize that homes are complicated systems that interact, and they need to be controlled. And if you want to be energy efficient, we can't just blow it out anymore. It's like the same thing in California with decarbonization. Like when in the late 60s and early 70s, when we switched to natural gas, that was better than burning oil because that was the best available technology. That's no longer the case. We have heat pumps, we have solar, we have battery packs, we have all these technologies. And I think we need to move with the times in that sense, and we need to start looking at the newer technologies, make sure that they're as efficient as claimed.
I agree, but I can tell you now, I'm getting excited for EBA and this panel and this discussion. I mean, it's the future that we're living in today, and that's something that we can grasp with proven technology. So I'm excited to be on this panel, and I look forward to EBA.
Same here.
And Aaron, this time I'm getting there one day ahead of time.
Great.
No plane cancellations.
Great.
Yeah, remember
Well,
that.
Those of you that are on, couldn't be more excited. Salt Lake City, October 10 through 12. We've got room for 600 this year. I think we're seeing a tremendous amount of builders that are looking at moving to the Zero Energy Ready Home program or the Energy Star programs. We'll be talking a lot about that coming up. But just to wrap things up, I want to thank Larry and Jay and Dr. Marcus Langer for being here with us today. And it's such a fascinating topic. And we just wrote an article called Heat Pumps Everywhere, because I think they're coming. But it's a new technology. We have to learn how to digest it. We have to learn how to properly plan it into the system. And I think a lot of great insight from each of you today. So I want to say thank you again.
Thank you.
Thank you.
Thank you for having us.
Darren.